This video will show us how to calculate the present value of a single payment, which we also call a lump sum. The present value is going to be the current value of future cash flows discounted at some appropriate discount rate. It could be a value at time zero on a timeline. If we want to find the price, we would be finding a present value. When we calculate our present value, we might answer the questions of how much do I have to invest today to have some amount in the future, or what is the current value of an amount to be received in the future. In other words, for that first question, if I want to know how much I need to save in the bank in order to have some lump sum amount in the future, perhaps to purchase a car, I'm trying to find out what single amount I would save today in order to do that. Our present value is the current value of an amount to be received in the future. So why is it worth less than face value? One example is opportunity cost. You could invest that $100 today and you would end up with a higher value than $100 in the future. So you might be willing to accept some amount lower today, knowing that you could invest it or save it and it would be worth that $100 in the future. Another reason is that there's some risk and uncertainty. Our discount rate is going to be a function of time and risk. We may be willing to accept a lower amount today, or some value less than $100, because of the possibility that maybe that $100 payment in the future is not certain. For example, if a person promised you $100 40 years from now, it's possible that you would no longer be friends with that person, or that person is no longer around, and so you may not be able to receive that $100 40 years from now. So you might be willing to receive some lower amount today because of the riskiness of receiving that investment or the amount of time associated between now and when that payment could be made. When we find a present value, we discount some future value to find the present value. And our formula is going to be that our present value is equal to our future value divided by the quantity of 1 plus r to the t. FV is going to be future value. And we see the subscript below FV, which is going to denote at what time period that cash flow occurs. PV is our present value. Our R is a periodic or period interest rate expressed as a decimal. In other words, if we earn 2.25% per year, and we would take our 2.25% and divide it by 1, because there is 1 year in a year. And T is going to be the number of time periods that we have. We'll also note that the value of 1 divided by 1 plus r to the t is what's known as our present value interest factor, or PVIF. And in order to help find that value of 1 plus r to the t, we might use our x to the y or y to the x, and then also our 1 over x or x to the minus 1 buttons on our calculator. Before we proceed, it's important to talk about r and t. Our r is going to be the rate per time period. Normally, an example will include a rate per year, and you will have to convert it to a rate per time period. So for example, if the bank said they were going to pay you 12% per year, and you were to earn interest on a monthly basis, you would take that 12%, divide it by 12 months in a year, and you would end up earning 1% per month. T is going to be the number of time periods. And so for example, if you were to earn interest every month for 10 years, then you would take 10 years times 12 months in a year to get 120 time periods. And examples and problems will usually make a reference to a number of years, and you will need to convert it to the number of time periods. In the next simple example, we are going to assume that interest is earned on an annual basis, and so we would simply divide our R by 1 and multiply our T by 1. So essentially we'll have an APR, for example, maybe 2.25%, and we would divide that by 1, and so we would still end up with our 2.25%. In some cases, one variable might be given as periodic, for example, an interest rate per time period, or the number of time periods, and the other in terms of years, and when that's the case, you will need to make sure both variables are periodic. So our time value of money inputs. Our time is going to be the number of years multiply the number of time periods in a year. So for example, if we have interest that we earn per month for 10 years, we would take 12 times 10 to get 120 time periods. In our formula, it's going to be denoted by T. Sometimes it's T times M or N. And on our calculator, it's usually an N. Our interest rate is going to be the annual rate divided by the number of time periods in a year. And so when we earn interest on an annual basis, or we pay interest on an annual basis, we are simply going to divide by 1 because there is 1 year in a year. How many years are in a year? Well, there's just 1. And so we would divide our R by 1. On some calculators, that interest rate would be denoted by an IY, or an I divided by YR, or some I or I%. Our present value is going to be the cash flow at time 0. In this next simple example, it's the value that we're going to determine today that we would have to save to have some amount in the future, usually denoted by a PV. A payment won't be applicable to this set of information, and our future value is going to be a cash flow in the future, or some amount that we need in the future. And so a simple example, you believe it will cost you $15,000 to attend graduate school 7 years from today. If you earn 2.25% in interest per year, we also call that an annual percentage rate, or an APR, by saving it in the bank, what single amount or lump sum payment would you need to deposit into the bank today to have the necessary funds? Another way to think about this problem is that what dollar amount today could you invest, earn 2.25% every year, and have $15,000 after 7 years? So let's look at our timeline. Our timeline shows the number of time periods. In this case, we're going to say that our T is equal to the number of years times the time periods in a year. Right? Since we're dealing with annual data, we would simply say that our T is 7 times 1 because there's 1 year in a year. So T is going to be equal to 7. Our interest rate, we take our APR and we divide by the number of time periods in a year that we're earning interest. In this example, we'd earn interest every year, so it's just 1. So our R is 2.25%. And our cash flow is a future value of $15,000 at time 7. And we need to discount that cash flow back to today to find the present value. And so we see our equation on the bottom left where present value is equal to future value divided by the quantity of 1 plus R to the T. And so if we want to solve that, we know that our R is equal to 0.0225. Our T is 7. Our future value at time 7 is $15,000. And so we can set up our equation this way, where our present value is equal to our future value of $15,000 divided by the quantity of 1 plus 0.0225 raised to the 7th power. And so what we get is $15,000 divided by 1.168539, which is equal to $12,836.54. And so there are a couple of different ways that we could type this into our calculator. We could take 1 plus 0.0225 equals, then our exponent button, or y to the x button, raise it to the 7th power, equals, and we find that's the value in our denominator, 1.168539. And so what we need to do is use our reciprocal function, our 1 divided by x, or x to the minus 1 button. So here we would hit 1 over x, and that gives us a value of 0.855769. And if we multiply that by 15,000, we get our value of $12,836 and about 54 cents. Another way to do this problem, if we use our BA2+, first thing we can do is clear our work. And we could use our parentheses, right, our open parenthesis and our closed parenthesis, in order to determine this value as well. And the other way to think of this problem is to use our open and closed parentheses on our calculator And so in this case, we're going to work on the part of the problem that is 1 divided by 1 plus r to the t, which we also call our present value interest factor. And so we might clear the value. And then we want to find 1 divided by the quantity of 1.0225. And we want to raise that to the 7th power. So we hit our YX button. And then we hit 7. And that's going to be the value that's in our denominator. So we're going to use our close parenthesis. And so now we have 1 divided by 1.168539. And we're going to hit our equal sign. And so now we have our present value interest factor, or the quantity of 1 divided by 1 plus 0.0225 raised to the 7th power. We multiply that by our future value of $15,000. And we find that we get that same value of $12,836.54. So we see there are a couple of ways that we could work on this problem using our calculator, our BA2+. When we first introduced the equation, we also said that there was something called a present value interest factor. In some cases, you'll see the acronym PVIF, again, where our present value interest factor is simply the quantity of 1 divided by 1 plus r to the t. And we can use the present value interest factor to determine our present value if we know some lump sum. And so in this case, we can solve for our present value interest factor and simply multiply that number times our future value in order to determine the present value today. And so the table below shows a portion of a present value interest factor table. And what we would do is we would go across the top of the table and find our interest rate per time period. Again, this is annual, so we would just use our annual rate of 2.25%. And we also figure out how many time periods we have. In this case, we have 7 time periods. And so using the column of 2.25% and 7 time periods, the intersection of those two columns So our 0.85577 is referred to as the present value interest factor, and we could simply take our $15,000 and multiply it by 0.85577 to get $12,836.55. There are also some relationships with our present value, and so if we hold our interest rate constant, or for a given interest rate, the longer the time period, the lower the present value. The reason that's the case is that if we're trying to invest a certain amount and we're able to save or invest for a longer period of time, that's a longer period of time that interest can be earned. And so it could grow to a higher amount at some point in the future given a longer time period to earn interest. The other relationship is that for a given time period, in other words, if we hold the time period constant, the higher the interest rate, the smaller the present value. The reason that's the case is that if we have a smaller amount but a higher interest rate, we are going to earn more interest per time period, and the gains in that interest earned will build up over time. And so here's a picture, right? So we have a graphical representation of the relationships that we mentioned on the previous slide. And we'll notice the present value of $1. At time 0 on the right side of the screen, you'll see that it's $1. That top line, the orange line, the solid line, shows that no matter the time period, which we see across the bottom of the graph, that if we discount at 0%, we're simply going to have our $1 no matter the number of years. The bottom line, denoted by 2 dashes and a dot, shows the changes in value from time periods 0 through 10. So one example, if we look at the present value of $1 discounted at 20% raised to the 0th power, in other words, If we earn 0 years of interest, then we still have our $1. And so if we're given 1 year to earn interest at 20%, we could invest $0.8333 today to have $1 after 1 year if we earn 20%. If we're given 2 years to earn 20% interest, and we want to find the present value of $1 that's received in the future, 2 years from now, we know that we would have $0.6944 today. We earn 20% per year, and that's going to give us $1 in 2 years. Using the same formula, we also find that if we are given 3 years to earn interest at a rate of 20% per year, we could invest $0.5787 today, earn 20% interest for 3 years, and have $1 in the future. We'll see our value for 5 years. If we were able to save 0.4019 and earn 20% per year for 5 years, we would have $1 in the future. And for 10 years, if we needed to have $1 10 years from now, we could invest $0.1615 today if we earned 20% per year. In this graph, we can see that if we hold our interest rate constant, in other words, if we use only 20%, as we increase our t, the present value falls. And the other relationship, if we hold our t constant, maybe at 5 years, we'll find out that as we increase our r, the present value falls.